This is the exceptionally unpleasant type of exam question that's been written specifically to test your understanding of the maths to the limit. As always, these questions are not actually so scary if we approach them from first principles. We know two time-of-flight equations. Time equals distance divided by velocity, and kinetic energy is equal to half the mass multiplied by the square of the velocity. And this equation here rearranges nicely to velocity equals the square root of twice the kinetic energy divided by the mass of a single ion. The question starts by giving us some information for the chromium-52 ion. We know the time it takes for this particular ion to drift down the flight tube, and we know the kinetic energy of the ions in this mass spectrometer, which means we can calculate the length of the flight tube. We can calculate a value for D. It's only once we know the value for D then we'll have enough information to actually answer the question and determine the time taken for a chromium-50 ion to reach the detector. Here goes. For the chromium-52 plus ion, we need to find the length of the flight tube. So distance equals time times velocity, which is equal to the time multiplied by square root of twice the kinetic energy of our ion divided by the mass. We know the time it took, 5.42 times 10 to the minus 6, and we know the kinetic energy of the ions, 1.56 times 10 to the minus 16 joules. But we need to figure out the mass of a single ion. 1 mole of chromium-52 ions weighs 52 grams per mole. So to find the mass of a single ion, all I need to do is divide 52 by Avogadro's number, 6.02 times 10 to the 23. And since we need this in kilograms, not grams, I need to multiply that by 10 to the minus 3. And when I plug all of that into my calculator, it comes out at 8.638 times 10 to the minus 26 kilograms. Now that I have the information I need, we can say that the distance, or the length of the flight tube, is equal to 5.42 times 10 to the minus 6 multiplied by the square root of 2 times 1.56 times 10 to the minus 16 divided by 8.638 times 10 to the minus 26. Plug all that into my calculator and the length of the flight tube comes to be 0.326 meters. Now we can find the time taken for the chromium-50 ion to drift the same distance. Going back to first principles, time equals distance divided by the velocity, and we know that the velocity equals the square root of twice the kinetic energy divided by the mass of a single ion, which means that the time taken for this ion to drift the length of the tube is going to equal the distance times 1 over velocity, or we could say the distance multiplied by 1 over twice the kinetic energy over the mass. And luckily that simplifies nicely to time equals distance multiplied by the square root of the mass divided by twice the kinetic energy. So we know the distance, we know the kinetic energy, we just have to figure out the mass of a single chromium-50 ion, and we'll do it in exactly the same way. 50 divided by Avogadro's number and multiply that by 10 to the minus 3 to turn our answer into kilograms, and the mass of a single ion is 8.306 times 10 to the minus 26 kilograms. Now we have all the information we need. Time taken is equal to 0.326 metres multiplied by the square root of the mass, 8.306 times 10 to the minus 26, divided by twice the kinetic energy. 2 lots of 1.56 times 10 to the minus 16. And put that into our calculator and it comes out at 5.32 times 10 to the minus 6 seconds, which is slightly quicker than the time taken for the chromium-52 ion, which makes sense because lighter ions travel faster. You can find notes, exam questions and answers at crunchchemistry.co.uk. Just search for Maths Spec.